Hello, everyone. We're back from the London Summit, and we talked a lot about IoT, machine learning, and a lot of new and exciting topics. And one question that came up is, where do I actually store this data, and does it live in databases, or how does this work? So I'd like to share with you a little bit about the current state of databases on AWS and actually storing the data once it comes through. So the first thing I'd like to show, the main service that we have for databases, as I believe most of you are using relational databases, is RDS. And I know it's a familiar service for many of you, but perhaps not for everyone. So let me share the most important points about our relational databases service. When you launch a database on RDS, the first thing to notice is we have a selection of engines here. So on a general sense, you use the same software that you use on your data center, on your machine for development. You can use the same MySQL, the same MariaDB, Postgres, Oracle, or even SQL Server if you're into that, right? And Amazon Aurora is our own engine. It's developed by Amazon, but it is compatible with MySQL and Postgres. So we have extra features for that, a lot more throughput that you would see on standard MySQL and Postgres, terabytes of auto-scaling storage and things like this. So the idea in this database engine is that it grows automatically, auto-scales up to 64 terabytes. And if you're into databases, thinking of a 64 terabyte database may be a bit difficult, but it's what Aurora was built for. And the way it works is it replicates data across 6 different availability zones. So across 3 different availability zones, so you don't run risk of losing data. And if one AZ eventually fails by a flood or a storm or a zombie attack or anything, you can keep using the service on other things. So let's proceed. Let's do MySQL, for example, or Aurora. Let's do both. So on MySQL, we can see the typical features that you would have, such as the selection of an instance type and this multi-AZ deployment. And this is a crucial, very important difference between Aurora and MySQL. On MySQL, you can select either 1 or 2 replicas, either one master or a master and a replica for high availability. And this is how the engine works, like how the same MySQL works for everyone. When you do Aurora, as I said, we have 6 replicas, 2 per AZ, so it's automatically multi-AZ, so that's why this option does not exist in Aurora. And I can call this my database and give it a username, a password. Oh. This is because this is not supported in the London region yet. Let me switch back here. Just a second. So let's continue with the MySQL case and use production MySQL. And you can select your version of MySQL and your instance type and all your database settings as we were talking. So MyDB, this is root. Password will be master key. And you have access to the default settings for VPCs, for networking. And I just want to show the very important features that you need to think about. Encryption, of course, is a very important one. You can encrypt your database and make sure that only the restricted people have access. You can connect with SSL and all the security features that you expect from enterprise-grade databases. And this backup setting is pretty important, and not everybody understands that we have this retention period that goes up to 35 days, and this is the time where we actually store your transactions log for your database. So we can roll back in time inside this window. So if you issued an update or delete without a where clause, you can roll back your database and sanity to any point in time within this window. And of course, the larger this window is, the more costs this backup incurs. So, and of course, this depends on the size of the database and how much it changed and things like this. But let's keep the full 7 days. And at any point, you can also take a snapshot of the database, and this lasts until you delete it. So this is the two ways you can back up a database on Amazon. You can either roll back to an existing state on point-in-time recovery, or you can recover from a snapshot that may have happened years ago. So that's how it goes. And this is important for auditing, for disaster recovery, and many other reasons. You can export the logs to S3 and many, many other interesting settings here, but I will just go over as we don't have a lot of time. This is all you need to get MySQL running, for example, on RDS. And the same features are available or similarly available for Aurora. You see, when we launch Aurora, you can select the post. Let's do a Postgres one. And here's the same thing, the engine and the instance type, and if you want replicas or not, and the same ideas. So this is MyDB, MyDB Aurora. It's root, it's master key, and that's it. I will go with default settings, and that's all you need to launch your database on AWS from the standpoint of a relational database. And again, there's a lot we could talk about on relational databases, just showing a couple different options. Here you can see they're being created, and in a few minutes they will be available, and you can connect to it, query to it, in the same way that you would with regular database. A few things to keep in mind is in Aurora, we have 2 new features announced at last reInvent that makes this totally different from the usual database on MySQL Postgres. It's one, Aurora Serverless is coming. So soon you won't need to create instances or drop instances or resize instances. It's going to work serverless. So you just have an endpoint, connect to it, send queries, and you pay just for the time that that query is being processed and the storage that it uses. And another one is Aurora Multi-Master. So here we have this distinction between primary and secondary nodes, as you would have in regular NoSQL databases. But in Aurora, now you can have multi-master replication and write to either nodes, and it will do synchronization and serialization of the transactions and conflict resolution, and all you need to have multi-master databases. So take a look at that as well. And that's it from the relational standpoint. Let me switch gears a bit to the non-relational side of things. So here in the console, we also have a service called Dynamo Db. So in Dynamo DB, you don't have the same structure as you have on a traditional relational database. On Dynamo DB, you can create a table directly, and let's say this table is events from IoT telemetry data or something like this. And the timestamp, for example, can be my key, or the device ID is my my primary key. And this is pretty important because this is how this data is going to be sharded, how it's going to be divided across your nodes that are back in your table. And I can add a sort key by a timestamp. And this would allow me to search inside this device ID. I want just the timestamps that are above a certain period. So this is the main criteria for getting data out of Dynamo DB. If you search by device ID or by device ID and timestamp, you can get data really, really fast, much faster than if you would search the entire table for this. And let's not use default settings here and talk about provision capacity. So the key idea in DynamoDB is that you don't need to provision or to understand the back-end infrastructure for this table. It will grow to keep this capacity at how much data you have. So if you specify 5 read units and 5 write units, let me disable all the scaling for now. So this would cost $291 a month, and this is how much you use your data. Like if you have 5 gigabytes, 5 terabytes, or 5 petabytes of data, it would provision the amount of hardware and infrastructure required to keep these units that you provisioned. So, and you can change this at any time without impact on your tables. So if you have a huge promotion coming or a corporate event, or at any time you need more reads or more writes, you can just say, hey, now I need, the event is on, we're live, I need 50 write capacity units, and it's just like that. It will cost proportionally, but you have this ability to scale up and scale down your database as you need. And although this is great, sometimes it's hard to determine like how much write capacity I need, how much read capacity I need. Like this floats a lot, may float a lot depending on your app. So we have this auto scaling for DynamoDB. So here we can say, hey, I want to auto scale my read and write capacities. So when it's at 70% utilization, I will increase the volume. And the same to you can do the same to the indexes that back your table. And that's all you need. Once you create a Dynamo table, it's ready for use in nearly instantly. So this won't take as much as a relational database would. And we'll be able to soon see the data. Let me see if in this other table I have some items here that I can add. And another important detail about DynamoDB is that it's schemaless. So when I create an item, see that we have resource ID and timestamp here, but I can create a new one that has a resource ID and another field. For example, anything at all. And it's 1, 2, 3. And you can see that now my table has this column, but this is just a UI thing because I don't need to alter table, create table. If I just add data, it will hold to that data as you would expect in other key value or document databases. And here you have the metrics, alarms, capacity, indexes, and everything regarding your data. I'd like to show some very new announcements as well. As we were talking about the new stuff on relational databases, I'm going to show some new features on NoSQL and Dynamo. First one is global tables. So if you have a global application, such as social media or any kind of global app, you may experience this problem that hosting the database on a single region may take a lot of time for this data to go from one place to another. So you may want to replicate this worldwide, and it brings all these challenges again of conflict resolution and how do you sync data and share it and stream it. So when you enable streams, you are just saying that you're okay with DynamoDB shipping your data out. And oh, this is not an empty table. Let me get those events and enable streams on that and add other regions. So now we are in Virginia. I will replicate to Ireland. So it's creating my replica table. It's creating this table on the Ireland region, and now it's there. So if I go to the data here and say that I have my device with timestamp now, let's see if I can get a better now. Yeah, now is okay. Pretend it's a timestamp. And if we go to the other region in Ireland, we have the events table there, and the items soon will be there, right? It's not. It may take a couple time before it set up and synchronizes the table, but it should be here soon. And let's go back to my original region and see if there is any indication on how that is replicating. Well, but that's all the setup that you need for having a global DynamoDB table that you can query or write from any region and have a truly global apps. If you've done this by yourself with other kinds of replication, you see how hard it is. You have your database engine needs to know if the client and the server, if they're if the replication is going to occur in the same region, if it's going to cross regions, because one is synchronous, the other is asynchronous, as you could see. And this is a bit hard to manage on yourself, and it's now embedded natively as a feature of DynamoDB. Another hard point with this amount of data and huge amounts of data is backup. So on DynamoDB backups, you can just back up the entire table, and as it's being enabled, now we need to take a break and come back to backups in DynamoDB once this table is created. Let's see if I can get it on this other table that I already have. So yeah, when I enable this, it takes a bit. And I can create a backup and say this is my now backup. And you can see that it's instant, regardless of the amount of data that you have. This is just the same time that you expect it to happen. And again, this is to support those two kinds of backup, as we were talking in the relational case. You can roll back to any point in time. So say you have completed an update and deleted items that you should, you can roll back to any point in time and recover your table to sanity. Or you can create a backup manually and saying, I want a snapshot at this point in time, and this keeps forever. You can roll back to it at any time. And also, we have embedded in DynamoDB something called the DAX. As we're going to talk now, a very popular thing to do with these DynamoDB tables and relational databases at all is cache them. So we have a separate service for in-memory caches, that's ElastiCache. In ElastiCache, you can create memcached or Redis clusters. So I can just come here and create my Redis instance and use it to or cache or use as a data store on my app. If your app uses Redis natively, that's a lot of cases. Again, the same mode easy with auto failover, so you don't have to set up high availability for Redis yourself, and the same setup that you would expect. But even so, integrating Redis and DynamoDB would be quite a task in some apps. So we have in DynamoDB embedded cache called DAX, DynamoDB Accelerator, that you can just create a cluster, and it will be fronting your DynamoDB tables and creating and caching in memory. So you can go from the 1 or 2 milliseconds that DynamoDB answers in really single-digit latency is the term that we use, so it's likely less than 10 seconds. But if you create a cache cluster, it will probably drop to 1 or 2 milliseconds or even to the microseconds range. So this is pretty important, especially for the IoT and high-frequency cases that we were talking about. And this is wildly different in many different customers. So for example, in many cases, we need search. So we have also services for that. And cloud search was initially what we had based on Solar. And now we have Elasticsearch based on Elasticsearch. And when you create a new Elasticsearch domain, it's your regular MyES. And you just say how many instances you want, the size, and Amazon will take care of provisioning, securing, and optimizing all those details that you would need by hand. I will just select that, go through with default settings, so you see what's the experience is expected here. Go with public access. You can not probably a good idea for production, go in this allowing everybody to access your search engine. But let's see if I can get this up. So open access to the domain is I accept the risk. And let's go. So this is all you need to have Elasticsearch, Kibana, and run your ELK stack, your databases, and things like this. So to sum things up, the idea here is that you can mix and match your favorite set of databases. If you're into analytics on relational databases, data warehousing, we have Amazon Redshift for that. You can have your star schema and use the same BI and DW tools that you're used to. Or if you're into NoSQL and high-scale databases for the famous web scale of data that is available as well as a service that you don't need anything to manage, backup, real easy, just integrate with your app and you're done. And another interesting scenario is that you're not coupled to this. Like, if you want to use the same MySQL that you have on your development machine, that's available. If you want to use Aurora, that's our implementation of a very effective storage engine, that's the same and at no difference to your app because it's the same protocol and drivers from standard MySQL, right? And even the Elasticsearch, the Redis, the Memcached, all that is available as a building blocks for your app, and we are here to help you be successful with it. If you have any questions, throw at us, and we would love to keep building together. Thank you very much. See you at the London Summit.